So in the beginning of this video, you're going to see that solving linear inequalities is just like solving equations. There are only two exceptions because this symbol requires sometimes to be flipped. I'm going to show you the two situations where that occurs. We start with a true statement. 4 is less than 10. And then we do what we're normally used to being a legal move to both sides of an equation, which would be to multiply by, say, -2. If we do that with inequalities, however, we would get that -8 is less than -20. And if we think about the number line, -20 is to the left of -8. So this is not true. And therefore, when you multiply or divide both sides of an inequality by a negative, a sign flip is needed. It's going to be your job to remember to do that when you work with inequalities. When you work with equations, let's say we had 6 is equal to 12 over 2. It's legal to flip both sides of the equation. In other words, reciprocate both sides. So in this case, you would get 1/6 equals 2/12, which is still a true statement. However, when you work with inequalities and you do that, for example, you start with 10 is less than 20 and reciprocate both sides, you get 1/10 is less than 1/20th, which is not true. And so this is the second situation where a sign flip is needed when working with inequalities. And again, it will be your job to remember to do that. Okay, so here's an example of a linear inequality. I know it's linear because x to the first is the highest power of the variable. If I treat this like an equation, then I would subtract 4 from both sides, and I would try to get the x terms on the same side, and so I would subtract 3x from both sides. Then I would divide both sides by 6, and I would get -4/6 or -2/3 is less than x, or x is greater than -2/3. Now, in calculus, we really prefer to write our answers in what's called interval notation, which means we're going to use an interval of the number line to describe the solution. So in this case, we are allowed to use all x values that are between 2/3 and positive infinity. Since I can't use 2/3, I use a parenthesis. Obviously, I have to use a parenthesis with infinity because we never get to infinity. If 2/3 was allowed, I would use a bracket. This is a compound linear inequality. There are 3 quote-unquote sections to it. You could break this up into 2 separate inequalities, or we can just treat this together. I'm going to treat it together. So to isolate x, I want to add 2 to all 3 pieces in this case. I don't want to call them sides. So all 3 pieces of the inequality. And then I will divide all 3 pieces by 3, which gives me 2 is less than or equal to x, which is less than 5. In interval notation, we will write bracket 2, comma 5, parenthesis. Okay? Which means on the number line, I'm permitted to use all numbers from 2 to 5, including 2, but not including 5. Now, very important, very important, very important. This is going to come up all year long. What is a sign chart? Okay? A sign chart is a partitioning of the number line. What does that mean? It means we take the real number line and we break it into pieces. Okay? Now, how do we break it into pieces will be determined by the inequality that we make. Okay? But let's say we broke it into 3 pieces and the pieces were set at 2 and 31. Okay? We then use each piece, okay, or a member of each piece to analyze the sign of our expression. So in this piece, perhaps everything is positive. In this piece, perhaps everything is negative. And perhaps in this piece, everything is negative. Okay? This analysis allows us to solve nonlinear inequalities. This third point here is important. The numbers that we use to partition the real number line, okay, these numbers here, are the values where our expression has no sign. Okay? So think about when something has no sign. That's when your expression equals 0, or if your expression is undefined. So what you're about to see with inequalities is a procedure that involves a sign chart and involves putting numbers on a sign chart to partition it, and those numbers are the numbers that make your expression 0 or undefined. All right, let's check it out. These are nonlinear inequalities. They cannot be solved like traditional equations. They must be solved with sign charts. Okay, so what do I need to know? I need to know, when does this expression equal 0, or where is this expression undefined? So off to the side here, I'm thinking x squared minus 5x plus 6 equals 0, or is undefined. Now, it's never undefined. It's a polynomial expression. We're all good. So I need to figure out what makes this equal to 0. So I can factor, hopefully, in many cases, and I'll get two answers that make the expression equal to 0. Okay, 3 and 2. Those are the numbers that will go on my sign chart. Okay, so I take the number line, and just a representation. These can be as far apart as I want. I just want to partition it. Okay, and now I have 3 pieces to the number line. I'm going to choose any member I want from each piece to do a sign test. So, for example, I need to choose a number less than 2. 0 is a great choice. Okay, so I'm going to test x equals 0 in this expression. 0 minus 0 plus 6 is a positive number, so that means that all numbers in this section of the number line will give me a positive result from this expression. I need a number between 2 and 3. Let's test x equals 5 halves, okay, 2.5. I have the factored version of this expression over there, so it's easiest to use that in this case instead of plugging it into the original. So if I plug in 2.5 into this, I'm going to get a negative, because 2.5 minus 3 is a negative, times a positive. 2.5 minus 2 is a positive. I don't need to know the answer, I just need to know the sign. So overall, a negative. So all numbers in this portion of the number line would give me a negative result. And finally, test any number bigger than 3. Okay, so we can test 10. Okay, that's going to give me a positive times a positive. Now, I've made my sign chart. I can answer the question. When is the expression less than or equal to 0? Well, that means negative. That's this middle portion. And since they used equal to, I may use the 2 endpoints of the partition. So my solution set in interval notation will look like 2, 3 in brackets. This is a very important point, and if you ever do this in class, you can count on me jumping on you about it. You never, okay, never multiply both sides of an inequality by an expression that has the variable in it, okay? Never multiply by expressions of x. You may be tempted to multiply both sides of this inequality by x minus 1 because you've gotten away with it with equations, and you probably could get away with it with equations, but in the inequality world, it does not work. You will mess yourself up big time because you don't know if what you're multiplying by is a positive, a negative, a 0, etc. It's not a good idea. So what do? Okay, we do kind of a similar idea to what I taught you with equations, which is to get one big messy fraction on one side and 0 on the other side. So if I do that, I have 0 is less than 2 over, I forgot to put the x over there, didn't I? Okay, 2 over x minus 1 minus x. Get one fraction. So this needs a denominator of x minus 1. So I multiply top and bottom of that fraction by x minus 1. And I have a denominator. Now, let's clean this up and then we'll be ready to rock and roll and do some analysis here. All right, what have I got here? I've got 2 minus x squared, be care of the secret agent, plus x over x minus 1. I don't like the fact that this is a negative x squared. So let's multiply everything in the numerator by negative 1 and also this side by negative 1. Recall what that means I need to do to the inequality side. I need to flip it. Okay, so I still have a 0 here, but now I have 0 is bigger than x squared minus x minus 2 over x minus 1. Okay, I now have one big messy fraction. Okay, what goes on the sign chart? Okay, what goes on the sign chart are numbers that make my expression equal to 0 or be undefined. So I can clearly tell right now 1 makes the expression undefined, so I can already put a 1 on there. And if I do a quick factoring job of the numerator, I'm going to get x minus 2 times x plus 1 in the numerator. So I have two numbers that make the expression 0. They are negative 1 and positive 2. So 2 is a partition and negative 1 is a partition. Okay, now I'm going to do a sign test for each of these intervals. I could use negative 10. Okay, so let's see here. That would be a negative times a negative divided by a negative. So 3 negatives is a negative. Between -1 and 0, I can test x equals 0. A negative times a positive times or divided by a negative. So that's 2 negatives and 1 positive. So that's a positive. Let's use 3 over 2 between 1 and 2. So a negative, a positive, and a positive. Overall, that's a negative. And we can use 10 for a number bigger than 2. All positives, so positive. Now, which ones do I want to use? Okay, I'm asked expression less than 0, so negative. So I'm going to choose these two intervals. And since it's just less than, I cannot use the endpoints. So all numbers between -infinity and -1. Don't include -1. Also include, so we use this symbol here, which means union. Union with this set. 1 to 2, do not include the endpoints. Okay, last example is an absolute value inequality. Once again, absolute value can be removed by writing plus or minus. So we have plus or minus 3x plus 2 is greater than or equal to 4. And my recommendation is to move this into two different inequalities. Okay, 3x plus 2 greater than or equal to 4. And the opposite of 3x plus 2 is greater than or equal to 4. Subtract 2, divide by 3 gives you x is bigger than or equal to 2/3. Multiply both sides by -1 means you need a flip. Subtract 2 gives you -6. Divide by 3 gives you -2. Now we can decide whether this is an and or an or statement. So I'm bigger than 2/3, but I'm also less than or equal to -2. So technically it's an or statement, but it doesn't matter to me because we're going to write our answer in interval notation. So we have -infinity to -2 with a bracket because I'm allowed to use -2. And we unionize, so 2/3 is allowed. We go from 2/3 to infinity.